Hi everybody, this is Mr. Folly again, and welcome to the next chapter of stoichiometry, which is the mathematics of chemical reactions. Oops. And we're converting reactants to products, or products to reactants, or reactants to other reactants, or products to other products, etc., etc., etc. So get your calculators out and your periodic tables as well. So the idea would be very similar to making tricycles. Let's say there's a formula for making tricycles. 3 wheels plus 1 frame makes 1 tricycle. Assuming you have an infinite number of frames, so I've got all the frames I could ever wish for, how many tricycles can I make with 9 wheels? Well, you know the answer is 3, but here's the math that you did in your head. 9 wheels times dividing bar, wheels on the bottom to cancel out wheels, tricycles on top, and then what you use to do this is, you know, you get 1 tricycle for 3 wheels. So when you convert into another substance, you use your coefficients. Okay? And our coefficients here, these would be like individual things or counting things. So this we would actually call moles, probably. All right. So again, we're going to always go through moles, but our coefficients are based on moles. So let's just do a bunch of examples and be done with it. So moles over moles use coefficients. So if I have 12.3 grams of KClO3, potassium chlorate, reacts, how many grams of O2 will form? So starting out with 12.3 grams of KClO3 times dividing bar, grams of KClO3 on the bottom, because I want to cancel that out, 1 mole of KClO3 on top. Little g stands for grams, and little g stands for go to the periodic table. So let's take a look for potassium, 39.10, plus 1 chlorine, 35.45, plus 3 oxygens would be 48. I got 122.55. And again, when in doubt, I went through moles. Now I'm going to cancel my moles and put moles of KClO3 on the bottom. And I'm going to put moles of oxygen on top. Now, this is the first time we've done moles over moles of different things. So I need a relationship between KClO3 and O2. So see that 2 right there and that 3 right there? That's my relationship. I get 3 O2s for every 2 KClO3. Or whenever you have moles over moles, use your coefficients. And I want to find grams of O2. So notice right now I've killed grams of potassium chlorate. I've killed moles of potassium chlorate. I'm now in moles of O2. I want to kill moles of O2 to cancel what I put on the bottom. And I want to go into grams of O2. Now, in this case, I don't have moles over moles anymore, so I'm going to go back to using 1 for moles. And little g stands for go to the periodic table. So 2 oxygens are 32. Get out my handy-dandy little calculator and go to town. 12.3 divided by 122.55 times 3 divided by 2 times 32. And I get 4.82 grams of O2. Not too bad. That's it. 2 KClO3 yields 2 KCl plus 3 O2, same equation. If 4.53 grams of KClO3 reacts, how many liters of O2 will be formed? 4.53 grams of KClO3 times dividing bar, what was that mass again? So grams of KClO3 on the bottom, 1 mole of KClO3, always go through moles, always go through moles. And the grams, we solved that just a second ago, it was 122.55. So I go to the periodic table and I add them all up. I don't know why I keep reading my L in KClO3. Times dividing bar. Now I want to get rid of moles of KClO3, and I want to go into oxygen, so again it's moles of O2. I have moles over moles, so I'm looking again at my coefficients. The coefficient 2 goes with KClO3, coefficient 3 goes with O2. Now I'm in moles of O2. I want to get out of moles of O2. It says how many liters? 22.4 liters equals 1 mole. And we'll assume we're at STP. That's it. Run it through my calculator now. 4.53 divided by 122.55 times 3 divided by 2 times 22.4 equals 1.24 liters. Now, I want to emphasize something here. And what I want to emphasize, first of all, is balance the equation. If it's not balanced, my moles over moles, it's called a mole ratio, will probably be wrong. If you don't balance it, you're going to lose most of the points for these. Next one. Wow, lots of things here. I've got numbers up here, the 2, so I know it's balanced already. If I have 5.67 times 10, this should be superscripted. To the 23rd molecules of O2 reacts, how many liters of CO2 will form? So I'm going to start with 5.67 E23 molecules of O2. Is O2 a molecule? Yes, there's 2 things. It's a little unit. So I'm going to put molecules of O2. I asked that question in case I have to deal with the atom changing thing or something like that. So I get out of molecules of O2, and of course I always go through moles of O2. 1 mole of O2 is 6.02 E23 molecules times dividing bar. And I've got moles of O2 on the bottom. And I want to go into CO2, so I'm going to put moles of CO2 on the top. I've got moles over moles in this case, and normally I've been putting ones when I have moles. But when I have moles over moles, I look at the coefficients. So O2's coefficient is what? 1. If there's nothing there, it's 1. That's not that crazy. CO2's coefficient is 2. And then it asks me for liters of CO2. So now I'm going to get rid of my moles of CO2. Go into liters of CO2. 1 mole, 22.4 liters. And do the calculator work, and that's it. 5.67 E23 divided by 6.02 E23 times 2 times 22.4 is 2.1 liters of CO2. That's it. 15.8 grams of silver nitrate is added to excess barium chloride. How many grams of AgCl will form? Oh, I have to write the equation now. So I have AgNO3 is added to excess barium chloride. Barium is Ba, chloride is Cl. I go to my periodic table, and I see that barium's charge is +2. Chloride's charge is -1, so I need to crisscross. So I would get 2 here and a 1 down there. Need to write my products. Barium's going to hook up with nitrate, so I get BaNO3 taken twice, and then silver chloride. Now I need to balance it. I need 2 nitrates, so I'll put a 2 here. That gives me 2 silvers and 2 chlorines, so I need a 2 here. Okay. Now that I've got it written and balanced, I get to start the Stoich. 15.8 grams of AgNO3 times dividing bar, grams of AgNO3, and then 1 mole of AgNO3. Going through moles as always. And the reason why I use 1 instead of 2 is 1 mole, I want to find the mass of 1 mole. So if I go to the periodic table, I'm going to find the mass of 1 mole, not 2 moles. So silver is 107.87 plus nitrogen, which is 14.01, plus 3 oxygen, 16 times 3 is 48. I get 169.88 times dividing bar. And then I want to get out of moles of silver nitrate and go into moles of silver chloride. So notice, again, I've got to go into moles of everything. If I haven't been in the moles of everything I've ever considered, I'm not doing it right. So here I've got 2 moles of silver nitrate, and I have 2 moles of silver chloride. I'm in moles of silver chloride, and I want to go into grams of silver chloride. So moles of silver chloride on the bottom, and grams of silver chloride on top. 1 mole, and then to figure out go to the periodic table for silver chloride. 107.87 is silver, plus 35.45 is chlorine. I get 143.32. Run that through my calculator. 15.8 divided by 169.88 times 2 divided by 2 times 143.32. And I get the wonderful answer of 13.3 grams AgCl. Review, always go through moles. Moles over moles uses coefficients. Now I always go through moles, and again, use 1 for moles unless moles over moles use coefficient. And you can change reactants to products, and that's pretty much the main point of this. You can change reactants into products, so you can figure out how much of something you're supposed to do, how much of something you're supposed to get. And we're out of here in under 12 minutes. What a great testing day podcast, and I'll see you in class tomorrow. Have a good one. Happy Halloween. Don't get too scared. Woo.